Source code written by us developers needs to be converted to executable programs. For this, there are two common techniques. A compiler can process the code and generate an executable program for a specific architecture like ARM, x86, or an Apple M processor. When programs are compiled for a specific architecture, static types can be used to optimize performance. For example, the compiler can decide to use hardware acceleration for specific operations. There is also a downside, of course, and that is that programs have to be compiled for each platform and architecture. The resulting binaries cannot be exchanged between platforms. An alternative is to create some kind of virtual machine for each platform. This way, the same source code can be used to feed each virtual machine, regardless of the platform it is running on. The Python interpreter functions as a virtual machine and does even more. It pre-processes the Python source code before executing it. For example, it performs syntax checks and then caches the file as bytecode. As long as the source code does not change, Python can use the optimized bytecode from the cache. Now, it would take a whole other course to explain all the possibilities, from interpreted code to binary executables. So let me focus just on Python. You know that you can give Python source code created on a Mac to someone working on a Linux machine. But you now also know that the source code will be converted to something called bytecode. In the right pane you see module calculator with two functions. In the left pane is a main script that uses calculator. Watch what happens when I execute the code. A cache folder was created. The cache folder contains Pike files, and if you have ever tried to open them, you saw something like this. This is called bytecode. But this code was not made to speed up the execution of Python programs, just to speed up the loading of the code into the interpreter by skipping the syntax check. And only when the calculator module changes, a new Pike file is created. Pike means Python compiled. Yep, Python does have a compiler to create bytecode. The bytecode is compiled for the interpreter that was used to execute the script. So what happens if this exact project is run on another Python configuration? Well, it is not common to ship source code including Pike files. My advice is to exclude them from your versioning system and let Python recreate them for you. In fact, you can delete the cache folder anytime and it will be recreated by Python. This recreation is done by the Python compiler. So yes, Python has a compiler. But its goal is not to check types, but instead to create bytecode that allows the interpreter to load the program faster.